All right, next up, we're going to take a look at heating curves, but first I'll ask you a question. You're going to boil a pot of water. Right, so you've got your pot of water. You're heating the heck out of it. Some of it's turning into gas, right? So it's boiling away. If you take the temperature of this water, you're going to about 100 degrees Celsius, assuming you're somewhere at sea level. And then you let that sit for a few hours, or maybe a few minutes or something. You let it sit for some amount of time. You see that the water level is decreased, right? That makes sense. It's kind of turning into gas, that kind of thing. What's the temperature of your water now? Now, a lot of people might say greater than 100 degrees Celsius because it was at 100 degrees Celsius and now you've continued to heat it, but that's actually incorrect. It's still at about 100 degrees Celsius, and it will remain at 100 degrees Celsius no matter how much you heat it. The more heat that you add, you can just increase the rate of boiling. And so the kind of trick here is when you reach a phase transition, so the melting point or the boiling point, all the energy that you add or take away doesn't go into changing the temperature, it goes into breaking these intermolecular forces. And this makes sense, right? We've done plenty of experiments where we've made a hot water bath, a boiling hot water bath. And no matter how long you sat there, you might have sat there for 10, 20, 30 minutes, you'll saw that it never really increased above 100 degrees Celsius. And so if we were to draw a heating curve, this is kind of what it looked like. On one side, we'll have temperature. On the bottom other side, we'll have the heat added. So as we go from left to right, we add more and more heat. At first, we start off with a solid, and as we add heat, the solid gets hotter. At some point, the solid starts melting. While it's melting, the temperature does not change, right? The temperature stays constant. So you're adding heat into it. Maybe your ice is melting, but it's still at about 0 degrees Celsius. Once it's all melted away, then it becomes a liquid. And once it's all liquid, the more heat you add, the hotter it'll get until you get to the boiling point. Once you're at the boiling point, again, even though you're adding heat, you're not changing the temperature of it. And then finally, when it's all turned into gas, you can superheat that gas if you would like. So the main thing that we note is that during the phase transitions, the temperature does not change. So that energy that you're inputting into the system, instead of making the molecules move around faster, you're helping them break these intermolecular forces.